This episode is brought to you by Champ Sports. Holiday deals have arrived, so stop by Champ Sports and save on head-to-toe looks. They've got the hottest selection of fleece, boots, sneakers, and more. Shop holiday gifts at your local Champ Sports store or online at champsports.com. Certain exclusions may apply, while supplies last and are subject to change.
Training, recovery, chocolate milk. Training, recovery, chocolate milk. Training, recovery. Chocolate milk is a super delicious post-workout drink, especially after loading up on squats for leg day.
This is SpaceTime, Series 24, Episode 82, for broadcast on the 19th of July, 2021. Coming up on SpaceTime, the ancient explosion bigger than any supernova, the Milky Way's supermassive black hole has a snack, and metal fatigue, or possibly micrometeor impact, the most likely cause of an ongoing leak aboard the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A massive explosion 10 times more powerful than a supernova, being described as a magneto-rotational hypernova, could provide the power to produce one of the most mysterious stars in the galaxy. The star is located some 7,500 light-years away in the halo of the Milky Way galaxy. A supernova is the explosive death of a star, a blast so powerful it can outshine an entire galaxy for weeks on end. An even more powerful explosion than any supernova is a hypernova, a blast generated by the merger of two neutron stars. And these have recently been confirmed as the source of the rapid neutron capture nuclear synthesis process, which is thought to forge the periodic table's heaviest elements. But that's still not enough to explain the levels or types of elements found in the spectra of this mysterious star. This unusually strong star-destroying blast, the magneto-rotational hypernova, is the most likely explanation for the presence of unexpectedly high amounts of very specific signature elements in this ancient star. These include zinc, uranium, europium, and possibly gold, all of which seem to have been detected in this extremely primitive star, catalogued as SMSS J200322.54-114203.3, its current address in the sky. The star is what's known as a population 2 star. That's a star produced directly out of the elements forged in the explosive core collapse supernovae, marking the death of the very first stars in the universe, known as population 3 stars. Population 3 stars are unique. They were produced directly out of the hydrogen and helium produced in the Big Bang 13.82 billion years ago. They're thought to have first formed somewhere around 300 to 400 million years after the Big Bang, ending the cosmic dark ages and triggering the epoch of reionization, the process which made the universe look the way it does today. Astronomers believe these population 3 stars would have been extremely massive, possibly even hundreds to thousands of times the mass of the Sun. They would also have been very luminous and immensely hot, with virtually no metals in their composition, except possibly for intermixing ejecta from nearby population 3 supernovae. By the way, astronomers refer to all elements as metals, other than hydrogen and helium, the primary elements produced in the Big Bang. And being so massive and luminous, these population 3 stars would have burned through their fuel supplies very quickly, living for perhaps just a few million years at most, rather than the 12 billion years our Sun is expected to shine for. And when they died, being so big, population 3 stars either turned into black holes or neutron stars, with much of their mass flung across the cosmos to feed the next generation of stars, those known as population 2 stars, the older stars still in existence today. But a report in the journal Nature shows that SMSS J200322.54 minus 114203.3 contains larger amounts of specific metals than other population 2 stars. Astronomers have calculated that only the violent collapse of a very early star, amplified by rapid rotation and the presence of a strong magnetic field, could possibly account for the additional neutrons required to produce this particular star. See, the star has an iron to hydrogen ratio some 3,000 times lower than that of our Sun, which means it's very rare and extremely metal poor. But the fact that it contains larger than the expected amounts for specific heavier elements means it's even rarer. One of the study's authors, Professor Gary DaCosta, head of the First Stars team in Astro 3D at the Australian National University, says rates and energies of these star deaths have become well known in recent years, so the amount of heavy elements they produce is also well calculated. But for this particular star, the numbers simply don't add up. The extra amounts of these elements had to have come from somewhere else. The authors have now found observational evidence for the first time directly indicating that there is a different kind of hypernova, one producing all stable elements in the periodic table at once, a core collapse explosion of a fast-spinning, strongly magnetized massive star, the only thing that could explain the results. Hypernova have been known about since the 1990s. In fact, high zinc abundance, such as that found in this star, is a definite marker of a hypernova, a very energetic type of supernova. However, this is the first time one combining both rapid rotation and strong magnetism has been detected. And this specific population 2 star was formed around 13 billion years ago out of a chemical soup that contained the remains of this hypernova. The star was first identified using the SkyMapper survey of the southern sky by the ANU Siding Spring Observatory, with follow-up observations then made using the European Southern Observatory's Very Large Telescope in Chile. DaCosta says its discovery reveals a new pathway for the formation of heavy elements in the early universe.
We've been using the SkyMapper telescope at Siding Spring Observatory in Western New South Wales to search for extremely metal-poor stars, stars that have abundances, say, less than 1,000th the abundances of the elements in the Sun. SkyMapper provides images, and it has a special set of filters that allows us to isolate candidate extremely metal-poor stars. We follow those up with the 2.3 metre telescope also at Siding Spring Observatory to see which ones really are extremely metal poor. And the best of those candidates we then take to the large telescopes in Chile to get detailed observations from which we can measure detailed abundances. And in that program, we came across this star, which has exceptionally high abundances of some of the elements that are made in basically neutron capture processes. And that's what set it apart from the other 100-odd stars that we have this kind of data for. The characteristics of this star is that it has high nitrogen, which is a signature of rapid rotation in the progenitor that produced the elements. The high nitrogen tells us that it was rapidly rotating because in a rapidly rotating star you get mixing processes that convert carbon to nitrogen. It has high zinc, which is an indicator that the supernova explosion that was the end of this star's life had very high energy, and that's why we call it a hypernova. We know from gravitational wave observations that you can get neutron-rich elements from the merger of 2 neutron stars, and that may well be an important source of so-called R-process elements as well. But we don't think that that could have happened at the very earliest times because you need time for the 2 massive stars to evolve, supernova, form the neutron stars, and then have those neutron stars merge. And this, that's going to take at least 60 to 100 million years. And we believe our star formed before that possibility. So we do believe that the R-process elements came from a magneto-rotational hypernova rather than from a neutron star merger.
Yeah, that was one of the big questions, wasn't it? Where were the neutron stars? There weren't enough of them around at the time.
That's right. There simply hasn't been enough time in the earliest part of the galaxy for neutron star mergers to have occurred. So this event would also have made some gold atoms. And then it has very high abundances of elements like europium, uranium, thorium, and barium. And those are elements that are made in processes that need lots of neutrons. And we think that those neutrons come from the magneto-rotational explosion of the hypernova.
And that hypernova would have been what, a population 3 star?
Yes, we can explain all the abundances in the star by the magneto-hypernova explosion of a single zero metallicity star whose mass was probably somewhere between 25 and 40 times the mass of the Sun.
What do we know about population 3 stars?
The first stars that formed, the so-called population 3 stars, consisted only of hydrogen and helium, essentially. And that meant that their evolution was different from stars like the Sun, for example, which has enough other elements to burn in a different way. Those first stars don't seem to have made any that have lived long enough to still be around today. All we can see today are the first generation of population 2 stars, the ones that formed from the ejecta of population 3 stars. So we can only learn about the population 3 stars by studying the distributions of different elements in the population 2 stars, the ones made from the ejecta. So we can learn about the masses of the stars, we can learn about some of the nucleosynthetic processes that went on in there, we can learn about their explosion mechanisms. But while we've been searching, the whole community's been searching for a very long time for a genuine population 3 star, we have never found, and we probably will never find, a star that really does consist only of hydrogen and helium. We don't think at the various early times in the galaxy's life that any low-mass stars that would have lived long enough to still be around today were formed.
What about things like James Webb? They'll better look further back than the 13.4 billion years of Hubble. Will that be far enough back to find population 3 stars, assuming that they were around, 300 to 400 million years after the Big Bang?
That's right. That's an interesting question, and we'll wait to see what James Webb actually shows. It certainly will be able to look back to the earliest epochs of star formation in what will be very distant, very young galaxies. Whether we can see an individual star at that point in time is hard to know.
So you'll see the epoch of reionization, you'll see the end of the cosmic dark ages, but you won't. Yes. You might not be able to see individual stars in that image.
No, you might be able to see a cluster of stars that probably even would still be unresolved. But again, smart people will make smart inferences from the observations and be able to learn what's underlying what we see.
Tell us more about SkyMapper.
SkyMapper is an ANU-led project that is in Silent Spring Observatory in Western New South Wales. It's undertaking a survey of the entire southern sky in 6 different filters that go from the ultraviolet part of the spectrum through to the far red. And basically it will ultimately produce a catalogue of something like 6 billion objects in the southern sky that people can access and learn about the brightnesses of stars, the colours, the temperatures. And when you combine that with the motions that we can get from the Gaia Space Telescope, we can learn a lot about the kinematics of the stars too, their orbits about the centre of the galaxy. So the survey's been going for about 5 years now. We've had 3 data releases. The data is publicly accessible at skymapper.anu.edu.au, and people can download images of their favourite part of the sky. We expect to finish the survey in about a year and a half's time.
Why are so many of the oldest known stars found in the halo of the galaxy?
Well, there's a fairly simple answer to that in the sense that we think the halo, which is the sort of roughly spherical region surrounding the disk of the galaxy, that was the first star formation occurred while the gas was still basically in a roughly spherical shape. It hadn't yet collapsed down into the disk where we see most of the star formation in the galaxy today.
Now, the fact that you've got an age for when this star formed of around 13 billion years, that must also therefore give you a set of parameters for when population 3 stars existed.
Yes, I mean, we can't actually age date this particular star. It's very hard to get the age of an individual star. So basically we're assuming that because it is so very metal poor, 1/3000th of the solar abundance, is that it did form at very early time. And models of how the elements build up with time suggest that you get to these kind of abundances about 60 to 100 million years after the first stars formed.
Okay, so this star could be much older than 13 billion years then.
We think we know the age of the universe from the analysis of the cosmic wave microwave background.
13.8 billion, and then 300 to 400 million years after that, we had the first stars form. That's when we think the first population 3 stars formed. And if they lived for maybe just 2 or 3 million years, would you think they were a bit like James Dean?
The fast star, yeah.
That's it.
But that's true. They're very massive, and very massive stars burn their fuel very quickly and explode generally, and leave behind, in most cases, a black hole.
That's Professor Gary DeCosta, head of the First Stars team at Astro 3D at the Australian National University. And this is Space Time. Still to come, our Milky Way supermassive black hole has a snack, And Richard Branson undertakes a successful suborbital test flight on Virgin Galactic's Unity rocket plane. All that and more still to come on SpaceTime.
Hey, I'm Ryan Reynolds, owner of Mint Mobile, with a message for everyone paying big wireless way too much. Please, for the love of everything good in this world, stop. With Mint, you can get premium wireless for just $15 a month. Of course, if you enjoy overpaying, no judgments, but that's weird. Okay, one judgment. Anyway, give it a try at mintmobile.com/switch.
New activation and upfront payment for 3-month plan required. Taxes and fees extra. Additional restrictions apply. See mintmobile.com for full terms.
Astronomers have come up with two possibilities to explain a sudden outburst of activity from the Milky Way's central supermassive black hole, Sagittarius A star. This monster black hole, which contains some 4.3 million times the mass of our Sun, is located around 27,000 light-years away at the centre of our galaxy. In fact, our entire galaxy appears to revolve around it. Supermassive black holes are found at the centres of most, if not all, galaxies. But unlike the very active supermassive black holes often seen blasting out powerful streams of material and energy from the centres of other galaxies, Sagittarius A star appears to be relatively quiet. However, in May 2019, Sagittarius A star woke up and began feeding on material accreting around the black hole's event horizon, a point of no return beyond which matter falls forever into the black hole's singularity. It suddenly produced an unprecedented near-infrared flare, more than 100 times brighter than usual, lasting around 2.5 hours. In fact, it was even more than twice as bright as any previously measured flare coming from Sagittarius A star. And it triggered an extended period of prolonged increased activity, with an unusual number of strong flares lasting at least half a year, the limit of the currently analysed data. Now, a report in the Astrophysical Journal Letters suggests the sudden increased amount of material triggering Sagittarius A star's sudden flare activity may have been caused by either disintegrating G clouds or shredding S stars. G clouds are thought to be either stars with extended gaseous envelopes or pure gas clouds, or a combination of both. Those orbiting near Sagittarius A star would lose mass through friction, as their orbit around the black hole stretches and elongates them, causing them to accrete mass onto the black hole at pericenter. The authors suggest that the 2019 flares from the galaxy's supermassive black hole could have been caused by accreting material drawn from the G1 and G2 clouds as their orbits reached pericenter. Now, alternatively, the authors are suggesting another possibility. You see, the dense galactic nucleus of the Milky Way hosts a population of around 10 million stars on very tight elongated orbits within a few light-years of Sagittarius A star. Now, this stellar population is made up mostly of red giants, with a significant smattering of massive supergiants, Wolf-Rayet A stars, as well as 100 or so OB blue stars. And all these stars shed mass through stellar winds. And when they swing close to Sagittarius A star at the pericenter of their orbits, this shedded mass might well have accreted onto the supermassive black hole, again triggering the observed flaring event. This is SpaceTime. Still to come, Sir Richard Branson undertakes a successful suborbital test flight aboard the VSS Unity, and a special investigation by the Russian space agency Roscosmos suggests the ongoing air leaks aboard the Zvezda module on the International Space Station were most likely caused by either metal fatigue or micrometeor impact. All that and more still to come on SpaceTime. Virgin Galactic founder Richard Branson has undertaken a successful suborbital ballistic test flight aboard the company's VSS Unity rocket plane. Unity was drop-launched from its jet-powered twin-fuselage White Knight II mothership Eve at an altitude of 43,000 feet above the New Mexico desert.
We have L-4 checks in work now, so we just passed the 4-minute mark. At this point, the pilots are ensuring the spaceship is in its launch configuration after going through the various L-10 checks, just confirming all settings are back in their place and go for launch. Now, this is also the point when Spaceship Unity will isolate her air supply from Eve and prime the rocket motor by opening the backup oxidizer valve. And once these actions are complete, the pilots are going to seek clearance for release from MCC. That's shorthand for our Mission Control Center. We have 2 MCCs supporting today. Our primary Horizon is located here at Spaceport America, and they're being supported by the Oculus Mission Control Center at our manufacturing base in Mojave, California. These teams consist of experts across various departments and disciplines within the company, and they're verifying checks with the crew today every step of the way. All right, and I've just heard from MCC that our L-4 checks are complete. We are roughly 3 minutes out from release at this point. It's getting really exciting, and we have just received clearance for release on time from Mission Control Center. So we are 2 minutes and 30 seconds out now. And once we get to the 30-second point, Spaceship Unity is going to arm the launch pylon. And then once we get to that designated point, the mothership pilots are actually the ones that engage the release, setting Unity free. So we have actions for both the mothership pilots and the spaceship pilots, so they're in coordination and all agree on the launch. The spaceship pilots are also going to push the stick all the way forward to prepare for release. And things happen pretty quickly after the release. So the pilots are going to light the rocket motor and they're going to accelerate in level flight until they reach Mach 1, at which point they'll start what we call the gamma turn, where we turn directly up and head to space. 1 minute to release now. It's getting real. 30 seconds. The Spaceship Unity pilots are arming the launch pylon now. We are armed for release. 20 seconds. 10 seconds. 5, 3, 2, 1, release, release, release. Clean release.
It then ignited its single hybrid rocket engine and quickly accelerated to over Mach 3 as it flew towards the blackness of space.
Ignition. Good rocket motor burn. There's Mach 1. Trimming now. Trim complete. Unity is pointed directly up and heading to space. Things are looking great. We are 25 seconds into the burn now, approaching Mach 2. 30 seconds, Mach 2. Everything's looking really good and stable. 50 seconds, approaching Mach 3. There's Mach 3. And 60 seconds, and that is a full duration burn, folks. We are headed to space. And the passengers in the back have been cleared to unstrap. Our predicted apogee is 279,000 feet and climbing. The pilots are now unlocking the feather, and as soon as they do that, it's going to initiate a backflip for Spaceship Unity. This is normal. We want those windows pointed down towards the Earth to maximize that incredible view. So feather is coming up now, and the pilots are also enabling the RCS, or reaction control system, which is what they'll use to control the attitude of the vehicle while we're outside the atmosphere. All right, feather is all the way up. We are at about 250,000 feet now and climbing.
After achieving apogee and enjoying a few minutes of microgravity, Unity began its fall back to Earth, eventually gliding to a landing on the same runway it had taken off from around 60 minutes earlier.
We reached apogee 282,000 feet, the culmination of a life's work, more than a half a century since the world rejoiced in and was transformed by humans leaving planet Earth. Sir Richard Branson fulfills his long-held dream of experiencing space with his crew. So we are on the re-entry portion of our flight now, and the mission specialists are heading back to their seats. Our training team has worked really hard on this portion of the flight to make it very natural and intuitive for passengers. Now, when we talk about space travel, a lot of people know and expect the boost portion of the flight to be loud and thrilling, but what's interesting is re-entry is also very similar, as supersonic air is flowing over the vehicle in the feathered configuration. Shock waves form on top of the cabin, which are audible to those inside. And for those of you on site watching on the ground, you should be able to hear a double sonic boom as Spaceship Unity once again breaks the sound barrier. All right, folks, we are now subsonic, just under 75,000 feet in altitude, and the pilots are lowering the feather now. Now, as the feather comes down, the nose of Spaceship is going to drop. This is normal and expected. Once that feather's down and locked, the pilots will begin a gentle pull up to a level attitude, and I'm hearing the feather is down and locked now. So at this point, Spaceship Unity is a glider, so it's all about balancing her potential and kinetic energy. So if the pilots want to go faster, they point the nose down, and if they want to go slower, they bring the nose up.
I've done some ridiculous things in my lifetime. That was really ridiculous. So I just can't wait for whoever did one day to be able to experience it. It's a complete experience of a lifetime. And now I'm looking down at a beautiful spaceport. Congratulations to everybody for creating such a beautiful, beautiful place. Congratulations to all our wonderful team at Virgin Galactic for 17 years of hard work to get us this far.
So we are at 22,000 feet now and descending. And as I mentioned earlier, Unity is a glider at this point. So the pilots right now are discussing their energy management plan. And pretty shortly here, they'll be meeting up with our Chase aircraft. The pilots are coordinating with Chase now and discussing their energy management plan. They're at about 9,500 feet in altitude, and the runway out here at Spaceport America is around 4,600 feet in altitude. All right, we have 3 landing gear down and locked. Now, the pilots are going to be landing on runway 34 today, so that's coming from the south and towards the north for those of you on site watching. And for the non-pilots tuning in, those numbers represent the first 2 numbers of the magnetic heading of the runway. So, for example, 34 is 340 degrees on your compass. We are just about 1,000 feet above the field now and on final, 500 feet above the runway, 300 feet over the threshold, main gear touchdown. And we're going to hold it just like this for a minute before bringing the nose down. And the nose is coming down now. Nose gear touchdown. And braking. And there is full stop.
All right.
A perfect landing. Virgin Galactic has just broken through the commercial space tourism barrier, and there is no turning back. We have just witnessed the second human spaceflight from the state of New Mexico, and our first spaceflight with 4 mission specialists on board from our operational home base, Spaceport America. A beautiful day of flight. What a moment.
Although heavily pushed in some media circles as a spaceflight, the mission once again demonstrated that the existing Spaceship Two design appears unable to actually reach space, instead achieving an apogee of 86 kilometres, 282,480 feet. Now that's well short of the 100 kilometre or 328,000 feet internationally recognised start of space known as the Kármán line, although it does surpass the lower American definition of 80 kilometres or 262,000 feet. The mission was the 22nd test flight for Virgin and their Spaceship Two rocket plane. Meanwhile, Blue Origin boss Jeff Bezos is gearing up for his own suborbital spaceflight tomorrow, a launch designed to celebrate the date of the Apollo 11 moon mission. Virgin Galactic's in direct competition with Blue Origin and its New Shepard rocket in the suborbital space tourism market, with New Shepard consistently exceeding the Kármán line during its test flights. Branson says Virgin Galactic will undertake at least one more test flight before it begins flying paying passengers next year. So far, more than 600 people have purchased tickets to ride Spaceship Two, each paying around $250,000 for the privilege. This is SpaceTime. Still to come, metal fatigue or micrometeor impacts, now considered the most likely cause for the ongoing leak aboard the International Space Station. And later in the science report, a new species of iguanodon-like hadrosaur dinosaur discovered in Spain. All that and more still to come on SpaceTime.
Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
An investigation by the Russian Federal Space Agency Roscosmos has concluded that the ongoing air leaks aboard the Zvezda module on the International Space Station were most likely caused either by metal fatigue or micrometeoroid impact. The Russian Zvezda module has been venting atmosphere into space since 2019. Cosmonauts found and eventually sealed a 5-centimetre jagged tear in the module back in October last year. But the Zvezda is still leaking air from behind an assembly compartment in the module. While the leak isn't serious, it has forced Roscosmos to send up additional air supplies aboard cargo ships bound for the orbiting outpost. Moscow now plans to have cosmonauts examine the Zvezda module's assembly compartment exterior hull during an upcoming spacewalk in order to determine if micrometeoroid impacts could be responsible for the leaks. If there's no exterior sign of micrometeoroid damage at the site of the leak, then the possibility of metal fatigue in the 30-year-old module will need to be considered. Roscosmos doesn't consider it to be a serious problem, as they plan to leave the International Space Station in 2024 anyway, taking several modules with them when they go, some of which, such as Zvezda, could be discarded. The rest will be used for the basis of a new Russian space station. Meanwhile, Russia's about to launch its new Nauka multi-purpose science laboratory module for the space station. The long-delayed Russian module will replace the Pirs docking port on the Russian section of the orbiting outpost. The 20-ton module is slated to launch aboard a Russian Proton rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan this week. Mind you, its arrival has been long delayed. It was originally slated to launch back in 2007, but ongoing technical problems have repeatedly hampered construction. In 2013, engineers found contamination in its fuel system. That resulted in a long and costly clean-up process, which ended up exceeding the safe use-by date for the components anyway, and that resulted in the need to build an entirely new replacement fuel system, which took even more time. And there have been ongoing niggling technical problems with Nauka ever since. Only time will tell if it really does launch this week as slated. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study shows that around a third of people who develop mild to moderate COVID-19 report lingering symptoms 7 months after infection. A report in the Journal of the Annals of Internal Medicine found that 38% of people diagnosed with COVID-19 were still reporting residual symptoms 7 to 9 months after their initial infection. These symptoms include fatigue, loss of taste or smell, shortness of breath, and headache. The World Health Organization estimates more than 8 million people have been killed by the COVID-19 coronavirus, with more than 4.1 million confirmed fatalities and some 190 million people infected since the deadly disease first spread out of Wuhan, China. Scientists say the growing problem of climate change is making heat waves more likely. A report in the journal Nature has found that the chances of temperatures in North America's Pacific Northwest coming close to 50 degrees Celsius has increased by at least 150-fold since the end of the 19th century. The authors say the heat wave would have been virtually impossible without the influence of human-caused climate change. Last week, California's Death Valley recorded a sweltering top temperature of 53.7 degrees Celsius. Mind you, Death Valley was also the site of the hottest temperature ever recorded on Earth, 56.7 degrees Celsius, and that was back in 1913. Meanwhile, Canada's highest ever recorded temperature of 49.6 degrees Celsius was recorded in Lytton, British Columbia just 2 weeks ago, and the next day that same village was almost completely destroyed by out-of-control wildfires which are now ravaging the Pacific West Coast. Paleontologists have identified a new species of iguanodon-like hadrosaur dinosaur in Spain. A report in the journal PLOS ONE claims the 6 to 8 metre long herbivore is based on a jawbone fossil unearthed at the Morella Subbasin dig site near Portel in eastern Spain. The newly identified dinosaur species would have roamed the Earth between 130 and 129 million years ago, during the Cretaceous period, and is similar to hadrosaur fossils found in Niger in China. Satellite images are showing Beijing is turning the disputed South China Sea into a cesspool of feces, with the mass discharge of raw human sewage destroying the coral reefs. The images, which span a period of 5 years, show how human waste and sewage have accumulated, producing huge algal blooms in a cluster of reefs in the Spratlys, where hundreds of Chinese fishing trawlers have anchored, plundering the rich fishing grounds around the reefs. The images, supplied by American geospatial firm Singularity, show at least 236 ships in the atoll dumping raw sewage on the reefs they're occupying. Beijing has claimed ownership of almost the entire South China Sea in violation of international law and is aggressively patrolling the region with People's Liberation Army naval vessels and Chinese Coast Guard ships. Intelligent design is the name creationists now use when they want to sound more scientific. Tim Mendham from Australian Skeptics says it's a term creationists were forced to adopt as the amount of scientific evidence supporting evolution became insurmountable.
Intelligent design is a term that's been used for about, 20 years, 30 years by creationists.
About that, yeah.
And creationists are people who believe that the Bible is literally true. The earth was created 6,000 years ago. Noah's Ark was real. Animals travel in Noah's Ark. Evolution does not exist. Certainly evolution between species. And that the answer to everything is God. And it was really, in the early days of creationism, especially in America, it was being put forward as basically a religious thing. We know what the answer is. Now we've got to find out the evidence to match our fixed answer. In some ways it was being parodied and pilloried as scientific as ghosts and UFOs. So what happened is that they then sort of changed the name and becomes intelligent design, meaning that the design did not just happen, as natural selection would say in design. Even the use of the term design is sort of misleading, but there is a plan behind it, there is a force behind it, designing the way the earth works, designing the animals and all that sort of stuff. It is creationism by another name, pretending to be scientific, but still, if the followers of intelligent design, and they're out there, especially in America where most of this stuff comes from, suggest that the many, and this is their quote from their suggestion of how to talk to skeptics and explain what intelligent design is. They say that many well-intended people reject not the actual theory, but a silly caricature, a straw man, by which they mean creationism. The religious fanatic who just believes that evolution doesn't happen. And they say that these people don't understand that intelligent design is not an argument from ignorance, but an inference to the best explanation based on positive evidence. Well, it's not. Intelligent design is about as scientific, as I said, it's about a study of ghosts and things, because primarily that they have an answer. The answer is that God did it, and then they try and find the evidence to suit. So rather than looking at the evidence, doing your research and saying, is there some sort of outcome we can get from this, they already have the outcome and everything else has to match it. And everything else is fiddled to match it.
What's the difference between that and creationism? There is
none. No. The case in America a number of years ago where someone was trying to push books, anti-evolution books, in, I think it was in Maine, and they were saying, oh, this is intelligent design, this has nothing to do with creationism. And then someone went through the book and pointed out that all you've done is do a word search and replace, and wherever it has creationism, you put intelligent design. And they would have weird sentences that just didn't make sense because of this substitution. And that was actually the evidence they used to point out that it is the same thing. You're just changing the name to make it more sciencey, and it's no more sciencey than creationism is.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient Metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
With Starbucks Holiday Blend for Nespresso Virtuo, now exclusively at Target, there are even more ways to share the joy. Savor every smooth and festive sip all holiday season with friends and family at home to fill every indulgent day with cheer.